Hey guys, this is going to be a quick video over independent and dependent events. So we're talking about probability here, and if we have independent events, that means that these events don't affect the outcomes of each other. They don't affect the probabilities whatsoever. But when we're having dependent events, that means that the first thing that happened affects the outcome of the things that follow it, which then changes the probabilities. So we're going to look at an example of independent first and then check out some dependent events. So let's say that we have this bag of marbles. There's 5 red, 7 white, and 8 blue marbles. First of all, I would always recommend finding the total number of the items that you have. So if we have 5, 7, and 8, that gives us a total of 20 marbles. So just kind of put that off to the side. That's going to be useful later. So we're saying that we are randomly selecting marbles each time we stick our hand in the bag. So we want to find the probability of selecting a red marble, putting it back in the bag, and then randomly selecting a blue marble. So how many red marbles are there in this bag? Well, there's 5. So the probability of choosing a red marble is 5 out of the total of 20 marbles. Okay, well, once we pick the red marble, we put it back in the bag. So all of the original marbles are there. Then we go back and we pick a new marble. So we're looking to see now what is the probability of selecting a blue marble this time. Well, out of the 20 marbles, 8 of them are blue, so the probability would be 8 out of 20. So the probability of choosing a red marble followed by choosing a blue marble, okay, I'm just going to call this the compound probability. If I can spell correctly here. The compound probability, the probability of choosing red followed by blue, would be the probability of choosing red times the probability of choosing the blue marble. So if we multiplied these, we're going to get 40 over 400, which would reduce to 1 over 10. Or you could say that there is a 10% chance. Now, if you're not sure how to convert that fraction into a percent, you are really just taking 1 divided by 10. You get that decimal, and then you can multiply it by 100. That number that you get is 10, so 10%. So either one of these would be an acceptable answer for me. The chances are 1 out of 10 or 10%. Okay, so let's take a look at the same scenario with one adjustment. Okay, we have the same bag of marbles, okay, the same number of each. There's still 20 marbles total. But this time, we're looking at the probability of choosing a red marble, setting it aside, and then choosing a blue marble. So the only difference is instead of putting the marble back in the bag, we're removing it and we're setting it off to the side, which means that there are fewer marbles total in the bag and fewer red marbles in the bag when we go to choose for the second time. So here's how that changes things. When we go to find the probability of choosing a red marble, all of the marbles are there. So there are 5 red marbles out of a total of 20 marbles. But since we're setting it aside, when we go back to choose a blue marble, we only have 19 marbles in the bag this time. So the probability of choosing a blue marble would be the 8 blue marbles that are left out of a total of 19 this time. So the compound probability here of choosing a red, setting it aside, and then choosing a blue would be 5 over 20 times 8 over 19. So we get 40 over 380. Okay, now we can try reducing this fraction here. Let's see, if we reduce this fraction, we're going to get 2 over 19. And let's find the percent of that. So 2 divided by 19, and then we're multiplying by 100. So that gives us about a 10.5% chance of that happening. So that's a little bit higher than the previous chance. Okay, before it was just 10%. Now it's slightly higher, it's 10.5, which makes sense because choosing the blue marble should be slightly more likely because there's fewer marbles total to choose from. So that's the difference between an independent and a dependent event probability question like this. Okay, you have a dependent situation where something is changing. In this case, the thing that changed was we actually kept the marble out of the bag once we picked it the first time. Okay, so we're going to look at a couple more dependent probability situations here. Okay, let's just say that we have 5 cards and they're numbered from 1 to 5 and then put in a box. Okay, we are going to choose a card randomly, set it aside so it's not going back in the box, and then choose another card randomly. So we're looking at what is the probability of selecting 2 even numbers. Okay, so I'm going to draw a picture here. Okay, we've got 5 cards and they're numbered 1 through 5. Okay, so we have 5 cards total. How many of these cards contain even numbers? Well, the only ones that have even numbers are 2 and 4. So the first time I go to pick an even number, so pick first even number. When we go to do this, 2 of the 5 cards are evens. So the probability is 2 out of 5. Okay, but now one of these even numbers, let's say the 2 is picked. Because that card is being removed, the second time we go to draw a card, the probability of choosing a second even would only be 1 out of a total of 4 cards now. So the compound probability, the probability of choosing 2 even numbers, would be 2/5 times 1/4. Okay, so that's going to be 2 over 20. Oops, that's not what I said. Not 20 over 2. 2 over 20, which would reduce to 1 over 10, which is going to give us a 10% chance. So again, something was picked, removed, so the second time we went to pick a card, there were fewer things to choose from total, and in this case, there were fewer even number cards to choose from. So that's what I mean by the first pick affected the outcome of the second pick. Things are actually changing from the first event to the second event. All right, one last problem here. So a game has 6 colored playing pieces. We have red, yellow, green, blue, purple, and white. You and a friend each pick a game piece without looking. What is the probability that your friend picks the blue piece and you pick the yellow piece? Well, there's 6 pieces and only one of them is blue. So when your friend goes to pick, their probability of picking a blue piece would be 1 of the pieces out of a total of 6. Okay, but now, since they're keeping that piece, there's only 5 pieces from you to choose from. Okay, well, out of those 5, how many of them are yellow? Only 1. So the probability of you then choosing yellow is 1 out of 5. So the probability of both of these happening in this order would be 1 over 6 times 1 over 5, which should give us 1 over 30. And then we can calculate the percent chance of that. So we do 1 divided by 30. We multiply that by 100. So it's about a 3.3 repeating percent chance. All right, guys, I hope that helped. I know that these problems are confusing, but just be on the lookout for things that are changing. Okay, for this example, if we would have put the original piece back, my probability of choosing yellow would have been 1 over 6. So always be on the lookout for something changing, like the total number of your objects changing and getting smaller like that. That's really the big difference between independent and dependent. With independent events, things aren't changing in between. with dependent events, things are changing from the first to the second events. So please let me know if you have any questions. Just reach out. Let me know if you're having trouble, and have a great day.